Thank you for coming to the meeting today. Data masking does not work. Try this instead. My name is Weston Goodwin. I am the creator of SQL Simulator. I've been a software developer for about 30 years, and most of that time has been spent doing something called Power Builder. And for those of you who know about it, you know about it. But one of the interesting things I have had in that career is that I've always been the youngest person on a team. So I've worked at several places, and I'm usually the youngest. There's never been a younger Power Builder developer than myself. So I guess I think they probably stopped teaching it in college around like 98, 99, and I must have been the absolute last student who had that class. So anyway, that's an interesting tidbit about Power Builder. I currently live in Richmond, Virginia. I am married with technically three children. Now that may seem like a weird statement, but I had custody of my sister, who is 17 years younger than myself, and there are no children in between us. So I was an only child from from 0 to 17, and then 2 weeks before I graduated from high school, my mom told me she was pregnant. So anyway, and so when our mother died in 2011, I got custody of her. So that's where I get the technically three kids from. This is the agenda for today. I'm going to speak about the issues surrounding data masking, talk about the tool I created called SQL Simulator, and show you a demo of how the tool works. The basic gist of data masking is to allow users to test or research production data in a secure manner. But there are several issues with this method. I'm going to review some of the issues now. The first issue with data masking is that it changes actual values in the data. For example, let's say you work in an insurance company. A customer called in because their homeowner's insurance jumped 50% from last year. The customer service rep was unable to determine why this happened. So you need to be able to see if their address falls in an area that has had an increase in crime, or if a batch job messed something up because they recently put in a claim. But because that data is masked, you are unable to determine what happened. Another issue you can have with masking, you get an email from your boss that one of the batch jobs went down. The log said this particular record caused an issue. And as you can see, there are like these invalid characters as part of this header field. Um, but however, the data masking would change that value, which you see down here, so that when you run the batch job on this record in a test environment, the batch job never crashes because the invalid characters have been removed. A second issue with data masking is trying to mask non-normalized data. Sometimes columns can contain more than one type of data in it. For example, the form header has a column name, address, SSN, and a variety of other pieces of data that are in specific positions. But in some systems, the position of the data can be different based on, for example, the insurance type column. I mean, imagine trying to write masking rules for situations such as this. It'd be very difficult. Okay. A third issue with data masking is that it can take days to mask an entire database. The larger your database, the more rules it has to go through. You can look at it like every record in your database could take 5 seconds to be able to have the tool go in and verify it and try to mask that one record. And then if you have like a billion records, at 5 seconds each, that's how you can get to a few days of it taking the data mask. A fourth issue with data masking is that it is impossible to check every record in the database to verify that it was masked properly. The last issue with data masking is that anytime you add new columns or tables, you have to spend time making sure your masking software is aware of it and update it accordingly. So, what exactly is a SQL Simulator? SQL Simulator recreates a structurally intact version of your database for securely testing or researching production issues. Each database can have as few as one SSNs across all of the tables. Any database created by the tool self-destructs after 15 minutes of non-use. Every request to create a subsetted database must pass through an automated audit. This audit restricts the number of SSNs that can be retrieved at one time, as well as how many SSNs can be retrieved in one day. Okay, let's discuss the business case for SQL Simulator. The first business case for SQL Simulator is that it won't expose all of your production data. Instead, give users access to a very small percentage of production data because you can restrict them to as few as one SSNs across all of the tables in the database. If a hacker hacks into one of these databases, they'll only get the one SSN that's in there. The second business case for SQL Simulator is that the databases created by SQL Simulator self-destruct after 15 minutes of non-use. A hacker can't steal data that's not there, right? Another business case is to limit the number of SSNs retrieved on a daily basis. This limit becomes a security feature. For example, you limit your employees to just 3 SSNs per day. They come in the next morning and are unable to retrieve any SSNs. That lets you know that you have an intruder in your system and you can notify your security team to try and remediate the situation. The fourth business case for SQL Simulator is that certain SSNs can require approval before SQL Simulator will retrieve them. The fifth business case for SQL Simulator is that it can help you stay under breach thresholds. Most jurisdictions in the United States have a threshold that has to be met before data breaches are disclosed to the public. For example, I live in Virginia, and so that threshold is 1,000 people. You must still notify the individuals that their information has been compromised, even if you fall beneath that threshold. For example, if you have 200 employees that need to access production data, and a hacker gets access to all of their username and passwords, then the most SSNs they could take that day would be 600, assuming you have limited each employee to 3 SSNs per day. The final business case for SQL Simulator is that it can reduce the size of your test servers. Why make several copies of a 10 terabyte database when you can make 100 copies of the same database at a fraction of the cost? This is a visual representation of how SQL Simulator can allow you to research or test production issues without accessing the entire database. In the middle of the screen, you see the words K8 cluster. That stands for Kubernetes, or that's shorthand for Kubernetes. This is where all of the databases that you use will be temporarily stored. The blue databases on the extreme right of the screen have sensitive data in them. The purple database at the bottom has no sensitive data in it. There is a black database, which is what SQL Simulator uses to determine if you can view the data. The users' computers that you see on the extreme left hand of the diagram are not able to connect directly to any of the blue databases which have sensitive data. They are only able to connect to the purple databases directly. For the demo portion of this webinar, we are going to pretend we work for GEICO, an insurance company. The DBA has set a data-governed limit of 3 SSNs per day, with only 1 SSN that can be retrieved at a time. So for scenario number 1, you get a call from HR. An employee did not get their paycheck the other day, and you need to research to find out why. Through a secure email, you are sent the SSN of 123456789. The first thing we need to do is to create a pod in Kubernetes, or in the Kubernetes cluster. A pod can be thought of as similar to a server. So, if I say we're going to create a pod in the Kubernetes cluster, you can think, okay, I'm going to basically just create like a server inside that cluster. And then the next thing we're going to do is upload a SQL script to view the results. All right. So for the first part of this, so in order to interact with a Kubernetes cluster, we first have to log into our cloud provider or, basically our cloud provider, and then we have to do port forwarding to be able to access a particular server or pod inside of the Kubernetes cluster. So the first thing we want to do is to get a list from Kubernetes of the pods, because we want the one that is the control panel that allows us to create the pods with SQL Simulator in it, as well as the database. So there's a list of the pods, and this is the one that is the control panel for SQL Simulator. So we're going to do a port forward with this pod name, and that tells Kubernetes that you want to access that pod through that port. All right, and so as long as we see this information, that means that we can now connect to the pod, and we will do that through a web interface. And the first thing we're going to do is put in the pod name, and then we're going to say, how much of a hard drive we want to reserve, and then we're going to select a database type. We're going to see that the pod was created. And so now what we need to do is to do another port forward to that pod that we just created. And this is our SQL Simulator interface along with our database. So as long as we see that information, that means we can connect to this pod. And the first screen you're greeted with is a pod initialization screen. You put in a username and password, and what this does is this is going to be your password and your username to be able to connect to the database that's inside of the pod. So I'm going to put a username and a password here. That'll take a couple seconds. And now we're going to upload a SQL script to test out, and I will show you what's in this script once I get everything set up. So all we have to do is upload a script, and the next thing we're going to want to do is configure our data source. So we have a source username, and then we have like a pod username, and then we have the connection information for both. So the source would be like your production database or whatever database you have that has the sensitive data in it. And then the pod username and password, that's the username for your pod. So I'll just put in the information if you can just give me a moment. Once our information has been put in, we just want to test that connection to make sure everything's okay, and then we are able to save the information. So the next thing we do is we click on the button on the left that says SQL Simulator, and then we click Preview Merge. So I am going to bring up the SQL. So we're going to do a select star from employees table where employee SSN equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the simulator created the tables inside of our pod. So if we want to view that information, we can just open up SSMS, and we're going to go to the pod, and we're going to connect. And this will take hopefully won't be more than a minute or two. We go to databases. We can see that there is a app prod database. We look at tables. And now we see that there are two tables here. Now, the interesting thing with this is that we only had one table that we were referencing in our SQL script, but it pulled two tables from the production database. And the reason it did that is because SQL Simulator has a tool or a feature that basically will pull any foreign keys and all the data for that foreign keys on your behalf, so you don't have to write a separate SQL script to do that. So let's look at the data in these tables. And the database is like a normal database. There's nothing special about it. You can do updates, deletes, you can do whatever you want to against this database. And as we can see, it pulled the data from production, and we can review it as needed. Okay. So you don't see what is causing the problem as to why the employee was not able to get their paycheck. The paycheck status on the payroll table is S, and that means his paycheck was sent. Then you remember there was another table called paycheck status you needed to check out. Since there is no foreign key from the paycheck status table to the employees table, you can create an on-demand foreign key. This way, SQL Simulator will retrieve the data for that table without you needing to write a separate SQL to do it. So we're going to pull up our SQL Simulator again. And one of the things that you may want to do whenever you're working with multiple tables inside of a pod is you will want to do a destroy merge. And what this will do is it's going to remove all of the tables that were created, so that you always have like a fresh copy of everything. So if I just do a refresh here, I'll see that those tables no longer exist. All right, so now we're going to do an on-demand foreign key. And once the SQL Simulator is running, I'll show you what it looks like on the inside of this file. So just give me a moment here, and we'll get it started, and then I will pull up the on-demand foreign key, and we'll talk about that. So the way this works is you have this @ symbol in the middle here. So you on the left-hand side, you have the table that will, if SQL Simulator detects this table inside of your SQL script, then it will build the associated other table and also pull the data for that table that's on the right hand side of the @ symbol. Okay, great. So we see that it has created the merge, and we go inside of our database tool, and we do a refresh. And now we see that there are three tables that are in here, and we can look at the paycheck status table, and we can see what happened. So in this instance, it did say that the paycheck was sent, but the status was returned to sender. So for whatever reason, that employee had like a bad address or something happened, and we can manually, give that employee a check, or whatever process we have in place to deal with something like that. So that is an example of how you can use this tool to review and research your data. So we're going to move on to another scenario, scenario number 2. So you and a developer need to make a change to the production database at the same time. You would like to see what happens if you run both of your SQLs against production. All right. So in this one, we are going to go to the simulator. We're going to destroy the merge. All right. So we can see that it's destroyed all the tables inside of the pod. And we're going to get rid of that. And we're going to get rid of that. And we're going to pick up the two tables that are in our scenario. So we have a developer's A SQL and a developer B SQL, and I will show you what those are after we run the simulator. Now this time I'm going to do a dry run, and what a dry run does is it basically does the same thing as a preview merge, which is basically build all your tables for you, um, but then it will execute the SQL script against the pod database and then destroy all those tables. And you're basically doing this to see, like, will my SQLs cause an issue in production if I try to run these? So we're going to go ahead and run those now. And then we are going to look at those SQLs. So developer A is doing an alter table, and they're adding two new columns. They're adding an effective start date and an effective end date. Developer B is basically trying to create a backup table. So they're trying to create a new table called plastic products, and they're just trying to do a select from the products table into that plastic products table. So we want to just see, like, if we ran those two SQLs in production, what would happen? Okay. Now we get a message: dry run has been completed. Developer A's SQL ran just fine. Developer B SQL came up with an error. Column name or number of supplied values does not match table definition. So in this case, what we should have done is we should have run developer B SQL first and then developer A SQL second. But this is one of those tricky things when you have multiple people trying to update production data and everybody submitting these SQLs. You can sometimes end up with issues that such as this, where SQLs don't get run, and then you got to try to figure out what happened, and hopefully it's not something that the boss is looking at, or or some type of resume regeneration event that will get you fired. All right, so now we're going to look at scenario number 3. So you get an email from HR. It was informing you of a end of year bonus of $20,000. But before it could be paid out, you had to install something on your machine. So of course you do it without thinking about it. The link installed malware on your computer. The malware allowed the hacker to steal your database username and password. It also gave them admin rights so they could take control of your computer. Why did you fall for this scam? Did you forget that they haven't given bonuses in a decade? Now we're going to pretend to be the hacker and see how much data we can steal from the database. All right. So I'm going to pull up the hacker SQL, and I'm going to run the simulator, and then we are going to review the SQL that the hacker put together. So this time, the hacker is just trying to take all of the records that are inside of the employee table. They want everything. They want social security numbers. They want addresses. They want names. They want it all. So we'll see how the system reacts if you try to do that. All right. So now we get this error from SQL Simulator that the sensitive data constraint has been violated. You tried to retrieve more than the allowed amount of 3. So as you can see that it did not allow you, it's not going to allow a hacker to just come in there and take everything. They're gonna be constrained by how many SSNs you allow per day. Now let's take a moment to review the audit table, and we can see who accessed the data. So now I'm going to open up my production database, And just give me a moment to bring that up. Alrighty. And there is a table called Tribal Knowledge Constraints, and there's one called Audits. So the audit basically shows you every time somebody tried to retrieve data from production. All right, so now we're going to move on to scenario number 4. Tom Brady is joining the Geeko board of directors. The DBA has added him to the celebrity table. We're going to now be a sneaky, nosy employee and view his data. All right, so we're going to go here to SQL scripts. We're going to delete all the files. And I'll show you what the celeb table looks like, or the celeb SQL looks like after I run the SQL simulator. Now we're going to get that started. And celebrity, here we go. So again, I'm going against that employees table. Employee first name is Tom, and then employee last name is Brady. So I'm trying to look up everything I can look up on the guy in our database because I'm nosy. Okay. Now we get a message stating that celebrity data was returned by your SQL. You need to modify it or get approval to view. So if you want to view his information, then we have to go to the constraints table. And I'm going to add my username. There's a record in the constraints table that says celebrity data, and it has the SSN on the employees table, and then Tom Brady's specific SSN, and that's a fake SSN. That's not his real SSN. So I need to put in my username for the production database, and now it should allow me to retrieve his data. So now I'm going to go back to the SQL simulator, and I'm going to do a preview merge again, and again, this is a SQL that I'm trying to run. And there's one more thing I want to mention about the celebrity data. Oops. So please note that if you try and retrieve celebrity data and are unsuccessful, this will count against your daily cap for SSN retrievals. So just know that. So you want to be careful, with this system and doing something like that. Okay. So now it let me retrieve Tom Brady's data. So now I'm going to connect to my pods database. All right. So now we see we have Tom Brady, his address, his SSN, and everything. Okay, so that brings us to the end of the demo. Here's my contact information. Again, my name is Weston Goodwin. I am available to do one-on-one install sessions as well as to answer any questions that you have. I want to thank you for your time and viewing this presentation, and have a good day.